Next, let us look at moving data into Hadoop. We will begin by looking at Flume's architecture, then examine the three modes it can run in, followed by a look at the event data model. Flume is an open source software program developed by Cloudera that acts as a service for aggregating and moving large amounts of data around a Hadoop cluster as the data is produced or shortly thereafter. Its primary use case is the gathering of log files from all machines in a cluster to persist them in a centralized store such as HDFS. Scoop is an open source product designed to transfer data between relational database systems and Hadoop. It uses JDBC to access the relational systems. Scoop accesses the database in order to understand the schema of the data. It then generates a MapReduce application to import or export the data. When you use Scoop to import data into Hadoop, Scoop generates a Java class that encapsulates one row of the imported table. You have access to the source code for this generated class. This can allow you to quickly develop any other MapReduce applications that use the records that Scoop stored into HDFS. In Flume, you create data flows by building up chains of logical nodes and connecting them to sources and sinks. For example, say you wish to move data from an Apache access log into HDFS. You create a source by tailing access log and use a logical node to route this data to an HDFS sink. Most production Flume deployments have a three-tier design. The agent tier consists of Flume agents co-located with the source of the data that is to be moved. The collector tier consists of perhaps multiple collectors, each of which collects data coming in from multiple agents and forwards it onto the storage tier, which may consist of a file system such as HDFS. Here's an example of such a design. Say we have 4 HTTP server nodes producing log files labeled httpd_log x, where x is a number between 1 and 4. Each of these HTTP server nodes has a Flume agent process running on it. There are 2 collector nodes. Collector 1 is configured to take the data from Agent 1 and Agent 2 and route it to HDFS. Collector 2 is configured to take the data from Agent 3 and Agent 4 and route it to HDFS. Having multiple collector processes allows one to increase the parallelism in which data flows into HDFS from the web servers. Oozie is an open source job control component used to manage Hadoop jobs. Oozie workflows are collections of actions arranged in a direct acyclic graph. There is a control dependency between actions in that a second action cannot run until the preceding action completes. For example, you have the capability of having one job execute only when a previous job completed successfully. You can specify that several jobs are permitted to execute in parallel, but a final job must wait to begin executing after all parallel jobs complete. Workflows are written in HPDL, an XML process definition language, and are stored in a file called workflow.xml. Each workflow action starts jobs in some remote system, and that remote system performs a callback to Oozie to notify that the action completed. The coordinator component can invoke workflows based upon a time interval, that is, for example, once every 15 minutes, or based upon the availability of specific data. It might also be necessary to connect workflow jobs that run regularly, but at different time intervals. For example, you may want the output of the last 4 jobs that run every 15 minutes to be the input to a job that runs every hour. A single workflow can invoke a single task or multiple tasks. either in sequence or based upon some control logic. This is the end of this unit and this course. As I said earlier, the components discussed in this unit have Big Data University courses that cover them in more detail. Thank you for attending. Here is a list of trademarks that may have been referenced in this unit.